Okay, in this video, what we're going to be doing is providing an introductory look at variables. Now, variables are not going to appear as anything new to you guys. You've been using them. You've used them in the Hyperion project. You've used them in the simple Windows application with the button that bounced all around. And we're going to be using them a lot in all of the applications yet to come in this course. Now, Logan, variables, they're kind of important, aren't they?
Well, they are, because if you ever need to store data or remember something, you'll have to use variables.
The key word, store. That's right. If you need to store information, you're going to store that information in a variable. Now, this video here is not going to make you an expert with variables. It's just going to provide you with a good general understanding of what they are. As a matter of fact, let's go ahead and talk about the objectives. In this video, we're going to talk about what variables are. We're going to talk about the different types of data that we can store in variables. We're going to see how we declare variables, and there's a couple of different ways that we can do it. We're going to talk about variable naming rules. Very important. Obviously, we must follow rules. There is no breaking the rules when writing an application. We're going to talk about naming conventions. Ooh, that's a hot topic between programmers. We're going to talk about working with variables. We're actually going to do it. We're going to manipulate some data. We'll create some variables. We'll store some information in them. We'll manipulate that information. We'll just give you a good idea of what's happening with these variables. And at the very end, we're going to tell you why you are still not an expert with variables. Don't worry, I know that might sound bad, but variables actually go a lot deeper than what we're going to present right here. There's things like, casting variables, the scope of variables, the lives of variables, etc. And that really doesn't fall into the scope of this video. The idea of this video, once again, is to give you a sort of foundation for what variables are. So with that out of the way, let me go ahead and bring up my trusty whiteboard. All right, so here we go, and we should be ready to write. So a variable. Well, Logan said just a second ago that a variable is a place for us to store information. So I'm going to represent a place to store information by drawing a container or a simple box. No different than if I wanted to store something in this house, I might take something into a room and put it into a box, and then I can go back to that box at any time and retrieve the thing I just stored, right?
Right, especially if you had some type of label on the box so that
So if I had a whole bunch of boxes in my closet and I stored different things in each of the boxes.
Look for the box labeled like socks or light bulbs or something.
Yeah, go get the socks out of my closet, which is in box labeled my socks. Yeah, that's an interesting one. Just a funny image that just came to mind.
Wait, but isn't that how you store socks?
Well, kind of, I guess. Okay, so a box. But what is it really? It's a place in our computer, in our memory, where information is being stored, where we can retrieve. I mean, with a variable, if we lose power and our computer goes out right now, and our computer comes back up, is that information still stored in that variable? As a matter of fact, let me put some information in here. We're storing the number 5, because for whatever reason, right now, I think 5 is an important number to store. So let's say I'm storing that in my computer right now and power goes out. Computer goes off. Power comes back on 5 minutes later. Do I still have 5 stored in my computer in that variable? No. It's been wiped out. All right, let's say I'm running my program, and my program creates a variable to store the number 5. Now I'm done running my program. Is 5 still being stored in my memory? No, it's gone. So a variable is only going to be there while your application is running. And even then, not in all cases. Only when it's within the scope of the method that's running or other particular reasons that may have a variable in place. But without the application, there is no variable. The application will be in charge of getting variables in place to store information. Now, what kind of information can we store in variables? Well, we can store all sorts of types of information, and that's the key word here. As a matter of fact, it's such a key word, I'm going to come in here and write it down. We have types of data. Now, there's a lot of different types available to us, and we're not going to cover all of those types right here. I just want to point out some simple ones. Now, first of all, what do I mean by types? Well, check this out. If I wrote down the number 13, okay, what kind of information is that, Logan?
Well, it looks like a number.
It's a number, all right? If I wrote down hello, what kind of information is that, Logan?
Well, that's a string of characters, or a string.
Just characters. If I wrote down true. Now, this is getting a little trickier because if you're a complete beginner, you may say, ha-ha!
That's also a word.
It's also a word. But notice how I didn't put it inside the double quotes. So this is more of a, so it's a literal value. It's true. It's rather true or not true, right?
Right, and not only that, it's limited in what it can be represented as, true and false.
Exactly.
Nothing else.
So, and let's see, if I wanted to wrap this up, let's say if I did, let's go back to 13, and I did 13.6. Everything that you're seeing here, these are all different types of data, and a very small showing of different types of data. We've got all sorts of types that we can store, and we have the ability to create our own types, don't we? They've seen it.
Right, so there really is no limit to how many, to the number of types that you may end up coming up with.
No, it's almost infinite. And you guys might be sitting there right now thinking, I've seen it. When have I created a type? Sure, you created a type. Remember, we made rooms, we made a game manager, we made a level, we made a player. Those were all our own customized types. So we have a whole bunch of intrinsic built-in types, and then we have, well, the ability to create almost an infinite number of customized types. So let's focus on just a few of the simple built-in types. And we've seen some of them right here on the screen. So let's put some proper naming to these guys. Let's start out with an int. Here's an example of an int. Let's talk about, oh, I guess I could follow it on over. A string. Bunch of characters. How about a bool? As Logan said, it is rather true or it is false. Oh, now we got this number down here, but we've already got numbers. Oh, there's a difference. Now let's put in a float. A float? What's different between a float and an integer? They're both numeric values. Oh, come on, look at the values. There's a difference. You can see it. An integer, which is an int, is a whole number. Some examples of an int. So, all right, let me do this. I'm going to draw a line. Well, okay. I'm going to erase that line because that was one of the scariest lines I have ever drawn. And I'm going to reach over here, and I'm going to hold the Shift key, and I'm going to draw a straight line. Whew, and I will try not to scare our viewers like that again. So an int, here's some examples. An integer would be something like 13, as shown above. Negative 26, 512, 0. Those are integer values. They are whole numbers, positive and negative. Now, we do not have an unlimited number of integers that we can use, meaning we can't put in the, 5,630,000. Integers can only go so high positively and so low negatively. Now, we're not going to get into how far we can go. That's going to come later because I want you guys to understand why they can only go so high and so low. And that's kind of outside of the scope of the simple foundation of what variables are. So we'll come back to that. Don't think I'm going to let you slide on that. But right now, just realize that an integer is holding whole numbers. Now, a float introduces a decimal point. So with a float, now I can come in here and do something like 13.68. I can do negative 12.229. I can do 0.65, etc., etc. Again, floats have a specific limit on how far they can go, positively and negatively. We'll cover that later. But the key here is, with a float, we have introduced decimals. Now, bool. Simple, simple, simple. As Logan said, we're looking at true or false. So anytime you need to store like a yes, no, or on, off, or true, false, you'd use a bool. Very simple data type, very easy to work with, right?
Exactly. Like you said, anytime you need to simply store, like, let's say you had a light in our Hyperion example. Let's say rooms had lights.
Okay.
And
cool.
The light being on or light off. You might have a light on bool variable.
Okay.
Which could be true or false. So true, the light is on, or false, the light is off.
Oh, what are you saying? They used it for real. Thinking about it, at the very end of the Hyperion project, our level designer, Mr. Zach, came in and said, hey, I'm going to create this really groovy game that's going to have areas that are off planet. And if we die, I need to know if we are off planet so that I can give a different death sequence as opposed to if you were on planet. Can you set that up for us? And the easiest way for us to do it was to create an is on world or on planet. However, what did we use?
I think it was is off world.
Is off world. There you go. And all that needed to be was a Boolean type value. True. Well, that means we're off world. False. That means we're still in the complex. Simple enough. So a bool, true, false. Very easy. A string. A string is going to store just a bunch of alphanumeric characters. So, as we've seen and used, hello world. Woo! That is a string. Now, for those of you that may have a little bit of C# background right now, you may be thinking, wow, check him out. He's just throwing strings in amongst ints, floats, bools. What's he doing? Well, at this point, we've been treating strings as if they were just a regular variable. Strings have a lot of power associated with them. But to truly understand that power, you need to understand what's happening under the hood with strings. And once we get into a deeper discussion of object-oriented programming, then we're going to revisit strings because there's some really cool things that we can do with them. But you need to understand working with objects, okay? But right now, I'm going to throw it in there because I can say string, my name, and in equals and in quotes, put Jason Busby.
Exactly. The way we're going to be using variables in this lesson, you can use a string in the same manner as you'd use an int or a float. Again, just making one and then storing something in it. That's a property that carries across everything we've shown here. Int, float, bool, string. They can all be written the same, used the same. They all work the same as far as we're concerned here.
Exactly. So the key thing that we're talking about is when creating a variable, you need to be aware of what type of data you plan to store in that variable. If I had a guitar, and I wanted to go out and get a container in the real world to store my guitar, I'm probably going to go buy a guitar case and put it in there. I am not going to use a leftover printer box that my printer came in and try to cram my guitar into that. That would be a no-no.
You're also not going to use a sandwich bag because you couldn't. A guitar won't fit in the sandwich bag.
No, it wouldn't. And it wouldn't fit. That's really good that you said that. That's the key thing. I mean, with all of these different types of variables, as you heard a second ago, I said, like with int and float, they have limits on how high and how low they can go. It all comes down to how many bits, how many bytes are we setting aside in memory to store that particular piece of information, that type of information. And again, that's something I do want to get into because that really helps us understand why we have these limits. But we'll do that in another lesson. So at this point, I have this box up here, and it just has a 5 sitting in there. I kind of need some code in place to show you how that box actually got there. And to do that, we have to understand how to create variables in our program. Now, creating a variable is called declaration. We're going to declare a variable, and that brings that variable, that memory storage location, into existence. So to do that, here is the basic syntax. So we're going to come in here, and we have to first tell it the type, and then we have to give it a variable name. Now notice how I am using these symbols right here. And you remember back, I'm trying to think, what was it I was giving them an overview of the structure of? It was something in a video lesson. I think it was
method structure.
Yeah, method structure. Now, when using this right here, this is not optional. These less than and greater than symbols is indicating that this is mandatory. And that's right, mandatory. So our type, so let's go ahead and bring this variable over here into existence. So I'm going to create an int, because that's what we're holding. That 5 is an integer. So that's the type. All right. Now I need to give it a name. Well, let's give it a very simple name. So I'm going to come over here and say int x. And I'm going to put a terminator. And this becomes a valid line of code. This creates a storage location that holds integers that is called x. Very important, that name. I now have a way to get to that storage location. Imagine if we had to actually talk computer language, right? Now, how many addresses are available with our modern day processors? Heck, if we went back to 8088, how many addresses were available? You had lots and lots of addresses available. Would you really want to remember a address, an actual memory location by an address number of like 5BFFA-C32? I mean, that's tough. But if I had a memory location called Game Lives, I can deal with that. Game lives. How many game lives do I have? Well, currently, Mr. Busby, you're storing 3 game lives in the game lives variable. The computer doesn't actually talk to you like that, but you can make it. But that's what's happening. You're storing that information in a variable that you can access easily through some sort of simple name that you've given it.
Exactly. Naming something is probably one of the easiest ways you can come up with for storing something. I mean, for example, if you look at a post office box where you have this wide array of different boxes and all they have is numbers on them, if you had to locate something without, if you didn't already have the number, well, to begin with the number, what do you have to do first? You don't just hone in on the exact box because they all look the same. You generally have to go box by box or row by row and say, all right, 501, no, 601, no, 7, and then it takes time to identify things. Where if you have a name, we as people can identify names much more easily. A name reminds us of an idea.
Right.
So if we had something called level instead of variable 45, level, it just clicks in our mind. It makes sense.
It does.
Whereas variable 45 doesn't. I mean, we'd have to bring up a sheet of all 50 variables we made and go one by one until we found the one we were looking for.
Precisely. Now, following through with this, how do we declare a variable? And we've seen int X. Now, the same thing's going to apply for all of these other ones. So if I wanted to create something to hold true or false, I could do bool, and then we could say, what was it? Is
the is off world from the
off
Hyperion
world. There we go. We have just created, let me throw it over here, another variable that's going to hold true or false. Let's currently put true in there. And it has a label, a way for us to get to it quickly, that is off world. Simple enough. Now, same thing's going to apply for float, string, etc. Now, this is not the end of all of our types. We have many more types, don't we, Logan?
Right. I mean, we have many more that are just given by default in C#, and of course we can create
an infinite number of our own.
Yeah, we can create our own. So
but for the intrinsic built-in types, there's a lot more that's available.
Right.
I mean, we can get into unsigned integers and I better not start saying fancy stuff.
Yeah, a lot of specific
chars. And, God, I gotta stop it. We'll have a lesson later, and I'll introduce some of these other really cool types. Let's keep to the basics. All right. Relax. Good. Okay. So now that we've seen how to declare variables, and we've talked a little bit about naming, let's focus on naming just a little bit more. Let's talk about our variable naming rules. And I'd like to start this off by first focusing on the first character of a name. So right here, first character. The first character of your variable name needs to be rather a letter, an underscore, I'm just going to put a little line there like that, or the @ symbol. So if I had underscore XPOS, that's valid. Ching. If I had XPOS, that's valid. Ching. If I had 5XPOS, that is not valid. You cannot start off with a number. You cannot start off with any crazy symbols if you want to go in there with a caret symbol or an opening parentheses. It must start out, must being the variable name, with a letter, an underscore, or the @ symbol. Variables cannot have spacing in them. Okay, so you cannot have a variable that's called my car. Instead of that, it would need to look like this. My car. Ching. Okay, very important. So when naming your variables, make sure that the first character of the variable name is a letter, an underscore, or an @ symbol. Make sure there is no spacing in them. You cannot use keywords. For instance, we have already seen that there is an if statement. There's an if keyword. So if we wanted to do a conditional test, we could say, if x equals 5, then do something. I can't come in here and say int if. And that is a no-no. We've also seen using. That's another one. You guys have done using system. You can't say int using. Any of the keywords, the words that belong to the C# language, you cannot use those as variable names. Keep that in mind. Very important. All right, let's see. Variable names, you cannot. Here's one. Case sensitivity. This is a funny one. It's almost like this isn't a rule, but I'm going to slap it into naming rules because it really kind of gets our beginners. We have all seen that I can come in here and I can do this. Int test. That's valid because test is not a keyword, and the first letter of the variable name is a character, a letter character. Now I can say int test. That's valid too. These are two different boxes. If I was to come up here and draw these in memory, here they are. So we've got test and we've got test. Oops. Like such. They are two different variables. Let me adjust that back down just a little bit. So let's say I put a 3 in one, and let's say the other one held a 100 in it, which was very important for whatever reason. The reason I'm throwing this in our variable naming rules is to make sure when you use a variable name, you stay consistent with that name. Don't try to give it a name of test with a lowercase and then turn around later in time and try to use it with an uppercase. If you haven't defined it, no problem. You know why? Because the compiler is going to keep you in line. It's going to say, no, that's a variable you've not yet declared, basically. But if you happen to have declared both of these, so this guy, and then forgot about it, and later in time crisscrossed them and got confused and started using the other one by accident, let's say you were expecting to get a 3, but since you typed it wrong with a capital in there, you got a 100, and let's say that didn't crash your program, but now that 100 introduced some other problem deeper in the inner workings of your application, and now, troubleshooting just became a monster because of such an innocent mistake. Please be careful. Watch this one. Anything you want to add to that, Logan?
No, I mean, the casing can be useful in certain cases when you want a lowercase test to represent something different than uppercase test.
Well, we've done it.
Right, when you want something similar, we've done it in cases where we had a private field and then have that private field be represented by a public property within something like a room or a level. So, I mean, it can be useful, but again, you have to be careful because the two names mean different things. If they were both defined, it's tricky if they're defined as the same thing. Where in your test, uppercase and lowercase example, because like you said, later in code we might forget what's what and just forget about casing altogether, and both of them will still work. So just something you have to watch for and be careful. It's usually something you'd want to use on purpose.
Right.
But
now let me step outside the scope of this lecture because you did say something that our viewers might be thinking back about. He just did this lowercase test and this uppercase test. I saw a whole bunch of stuff like this. For example, title. When we did our rooms, if you recall, when we created the classroom inside there, we had a string variable called title. But then we turned around and we created a property that was called title with a capital T. So that's what Logan's talking about. That string variable title, that was a field member of the class. It's still a variable. I mean, if you really want to get down to it. But it was a field member. Again, this is outside of the scope, and this is something we're going to be looking at when we get into the discussion on classes and objects and how all that works. But just in case you think back and remember that, that's what was going on there. But what we're talking about right here is if you come in and you declare two different variables, same name, different casing, be careful. This is bad practice, and you can get yourself in trouble real fast. All right, so that's variable naming rules. From there, what I want to spend just a second and talk about is going to be naming conventions. All right, so with naming conventions, what are we talking about? You know, and if I follow your rules, can I name my variable anything I want? Well, the answer is yes. But do you want to do that? The answer is no. You're going to want to try to come up with a descriptive name for your variable. If you have a variable that is going to hold, for instance, a player's X position, you don't want to call the variable hamburger. Hamburger is a valid name. How do I know that? Well, there's no spaces in it, and it starts out with a letter, H. Now, later in code, if I saw hamburger equals 6, why does a hamburger equal 6? If another programmer came in and looked at your code, they're really going to be scratching their head. And check this out. A year later, if you haven't looked at that code for 365 days and come back and all of a sudden you focus on that one area, you might think, why am I setting a hamburger to 6? It doesn't make any sense. But if you did something like position X, all one word, well, that might make a lot more sense. You could come back a year later and say position X equals 6. Ah, I'm setting something's position X to 6. That suddenly makes a whole lot more sense. But now that we know that we need to use some sort of descriptive name for our variable, we have some suggestions for the naming convention to follow, that you should follow. Now, all the way up until not too terribly long ago, the Hungarian notation was a very popular naming convention that programmers liked to use. Now, what was the Hungarian notation? Well, it was simply taking the first letter of the data type and putting that as the first letter of your variable name. Huh? That's what some of you guys might be thinking. Well, let me give you a demonstration. So if I come down over here and I did int, let's say we're going to do X position. You may have gone int I X POS. Okay? Notice the first character right here matches first character of the type. Another example. Let me go and scroll down if you guys don't mind. This will make life a little bit easier for me. There we go. What if I did a Boolean? So I had a bool, and I was going to do is off world. It would look like this. B, and then is off world. Once again, we're in a situation where the first character is going to match the first character of our data type. Now, we have the ability to create an almost unlimited number of data types. I mean, it's about infinite, okay? Well, how are you going to represent that first letter if we use the Hungarian naming convention? If you had, we got room, level, we had game manager, we had player, we had tons of different types.
Or what if you were writing a program where you had player, you had point, you had particle?
Ooh, I like it.
And what letter should you use if you were trying to use Hungarian notation?
Ooh, I love it. P. Oh, which P goes? It's so confusing. So Hungarian naming conventions, the Hungarian notation naming convention doesn't really work that well. So a lot of people started moving over to camel casing or Pascal casing or a combination of both. Whoa, what are you talking about? Let me give you a demonstration real quick. I'm just matter of fact, let me do this. I'll just draw a line over here, and we'll do some drawing over here. Boy, I'm lighting this whiteboard up tonight. So camel casing. What does camel casing look like? Well, let's come up with some variable names. Level. How about lives? How about game count? Because that's 2 words. Notice how the first character of each of these variable names is lowercase. Now let's take a look at Pascal casing. So with Pascal casing, check it out. Level, lives, game, count. So notice the difference here. With Pascal casing, our first character is capitalized. With camel casing, our first character is lowercase. But notice how when we're dealing with a variable name that consists of multiple words, game count in this particular example, each new word always starts with the capital letter. And this is just to make it easy to identify the name when you're looking at it. Because when you just look at it and each new word starts capitalized, your brain's able to kind of break it up. Because remember, we can't have spaces in our variable names.
Right, so if you wanted to have some descriptive variable and you needed to use a compound word or multiple words to describe that, you still need some visual indication of where the words are separated. Because like you said, obviously you can't have a space in a variable name.
Right. So what is recommended? What kind of naming convention should I use? Well, here's what Microsoft kind of says, and I'm just going to really summarize this like crazy. Simple, more complex. What do I mean by that? Well, function parameters. We've all seen them. Let me try to think back. When we did, remember when we created the what was it, like add, the method add numbers? I'm going to abbreviate the heck out of this. So add nums, what did add nums take in? It took in some parameters. Let's say it took in an int. And remember how Logan went num a, comma, int, num b, like such? And let me come over here and change this. This whole thing will work because this is just me writing stuff out real quick. You see what I'm doing, Logan?
Changing the name of the method.
Yep, there we go. So these are what? They are function parameters. So function parameters and local variables, just all your simple variable types, use camel casing. So start them out with lower cases. The way to identify, just think simple. Your more complex names that we're working with. In this case right here, now we're dealing with something a lot more complicated than just a simple parameter. We're dealing with a method, and this method has functionality. So in this particular case, we want to use Pascal casing. So you could just think simple, complex.
I know just two more words to throw out there. A way I sometimes think about this is that you use camel case for something that's very specific, and Pascal case for something that's more general or more widely used.
Okay.
But I mean, for something that's very specific, like a variable you're going to use for only 2 lines of code, just inside of something, or a parameter to a method, something that's specific to that method, use camel case. For something that's widely or generally used, like a method that may be used by a lot of different things, Pascal case.
Exactly.
The name of something that you've made, like the name of something general, like your overall level, your player, your room.
Well, think back to the fields. I mean, every time you created a field, which is just, it's a variable, but it's a...
Call it internal, maybe? Internal to the...
To the class. I mean, so it's a variable for the whole class, if you will. But every time you made one of those, it was always lowercase. But then when you created the property to assign information to it, then the property, you always used the same name, but now it started out with an uppercase.
Right, and then that was so that you could access the property from outside of that, from outside of the room. You could look at the room's properties.
Right.
And that would be, again, more of a widely used thing, because anything could look at a room's properties.
Exactly.
Look at its title.
And so that's using Logan's way of thinking, and my way of thinking is the property is definitely more complex than just that field member or just that variable. Because the property contains structure, and inside the structure it has a get and a set and all this.
Whereas the field is just a value.
It's just, hello, I'm just a little variable. Exactly. Okay, so hopefully at this point you guys are starting to get a little bit of an idea about variables. They are a place in memory that is going to store information for us. We have to determine ahead of time before we create one of these variables what type of information it's going to store, the data type. And we've looked at some simple things, int, string, bool, float, and we said there are plenty others out there. And we've also talked about the ability to create our own, which you guys are going to be doing a lot of in the future. So now that we've looked at all that, it's time to go ahead and start focusing just a little bit closer on some code. So there's several things I'd like to do. Let's go ahead and start talking about declaring. So let me bring up this guy here. And how about I just create another board real quick. That'll work for me. And I'm just going to jump back up like such, so I have space to go above and below if I need to. And let's get back into declaring. So declare. I'm going to declare a variable, int x. And we all know what this does is it creates a place that I can store information in the computer and labels it X so that I can get back to it easily. Now, At this point, if this is my entire program, what's in X? Nothing's in X. We have not initialized X. So now I'm introducing a new word. We need to initialize X, meaning we need to put something in it. So if I turned around right now and tried to do a write line and write out what's inside of X, the compiler's not going to be too happy with us, is it?
Right, it wouldn't even let you compile because it would notice that you never put anything into X.
That's
so
right.
X is unassigned.
So we need to assign something into X. So to do that, if I was to come in here on the very next line and set X equals 5, Terminator, now what did we just do? Ding, 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 ding. Burn. We put a 5 into X. So we're now storing information in there. So we are declaring on this line, and we are initializing on this line. Now if we try to do a write, everything's going to write just fine, isn't it?
Right, there's a valid value stored within X, so you can look into that value, get it out, and use it.
So let's make this right here. Let's go ahead and bring up C#. I don't know if we cleared it or not. If it's not, it's okay. Let's go ahead and just pull it up.
Okay, and begin...
Yeah, just go ahead and close that out. And let's do something real simple.
All right, I'm going to bring up a console app so we can get to working with stuff really quick.
Okay.
Now, like you're saying, let's define an integer called X.
So let's declare it. We're going to start out with int X. Dun-na. Now try to write that out so they can actually see it.
All right, let's grab our console. Let's tell it to write line. We'll tell it to write out X. Now, what happens if we compile?
Use of unassigned local variable X. Now, first of all, the term local variable is something we're going to start talking about a lot heavier in the near future. I just want to throw that out there. We will cover what local means. But notice, X has not been assigned. We need to put some information into that memory location that we have now set up for ourselves. So Logan, let's go ahead and initialize X on that next line with X equals 5. All right, and now if we run it, what do we get? Well, first of all, you just compiled it. Notice all the errors went away. The compiler is happy. So let's hit F5. And, okay, let's go ahead and have it pause for us.
So we'll have our console.
Quick read line in there. All right, so here we go. Ha! In our memory location, we are holding the number 5. Excellent. Okay, let's go ahead and close. And now what I'm going to do is jump back over real quick to the whiteboard. Now, let's say on the very next line of our program, I came down here and I did this. X equals 8. This is so important to understand. I have had many beginners in the past get confused and think, well, X is a memory location. It is a storage container for data. So can I just have 8 get added into there? And I kid you not, here is how some students have visualized this. Some students have visualized this as X, hang on, there. X is containing a 5 and an 8. And some students have visualized it as an 8 and a 5 is what? 13. But it added that to it. No, it did not. It replaced. Watch how I do this. It replaced the value that was in there with a new value. 8 is now in there. 5 is gone. It is not 5 and 8. It is not 5 and 8 added together. This line said create it. This line said assign 5 to it. This line said assign 8 to it. It doesn't care what is in there. If the very next line looked like this, X equals X plus 2, ooh, now we're getting sophisticated. Let's take this and look at what's happening a little bit closer over here. So, here's X, which currently contains an 8. And X is going to be equal to whatever is currently in X, which is an 8, plus 2. Well, what is 8 plus 2? 10. So after this line is executed, 10 is what is put into x. So to visually represent this properly, actually, you know what? I'm just going to, instead of doing it that way, bear with me, guys. You'll see. There we go. Instead, the next thing is going to look like this. X has a 10 in it. There we go. So you can follow it on down. You can see the flow. Very important stuff. We're just simply assigning values into X. That's what you need to remember. Now, Logan, if I come in here and say X equals true, what have I just done?
Created a type mismatch?
I sure did. I just tried to cram my guitar into Logan's sandwich bag that he got earlier. We have two different types of data here. X holds integer types. True is a Boolean type. Can you go try this out for me over there?
Sure.
Let them see this.
All right, let's go. Maybe just jump down here and say X equals true.
All right, let's compile that. Cannot implicitly convert type bool to int. Ooh, convert, nice word. It's saying that I cannot convert your true Boolean value into an integer. From some of you that are coming from other languages, you might be able to do things similar to this. Not in C#. You cannot do this, okay? Yes, you cannot do this. I was looking for other ways in my head of casting and stuff, but we're just going to leave it like that. You can't do this. So, Logan, I do want to go back. Now that they've seen us trying to cram the wrong data type into here, let's go back to X equals, and instead of true, set true, the word true, to 13. Now, before you hit run, here's just what I want to point out real quick. So, what's happening here? We are declaring our variable X. What's happening here? We are putting the value 5 into X. What is happening here? We are replacing the value 5 because we are assigning a new value to X. So X is 13 at this point. We come down here. We write out what is in X. It's 13. Run it. Let's take a look. 13. Very nice. Now do this. Go ahead and close the console. And after the write line, let's do something else fancy. Let's say X equals X plus, I know we could do plus equals, guys, now that those of you are familiar with that as we have introduced it earlier. Let's keep simple here. So X equals X plus 5. Terminator. Now, in this particular case, let's go ahead and jump down to the next line and write this out so that they can see what is being stored in X after the line before it executes. So now, X is, again, this is going to get boring, but important. X is declared. X is set to 5. X is overwritten with 13. We write 13 out to the console, so that's what we see. Then we come in here and we say, we got to solve this side. Once we solve it, we know the answer to put into this side. This is because of us using an assignment operator here. We'll talk about operators coming up soon. So X is what? 13 plus 5 is what? 18. Take the result, put it into here. Next line, write it out. Let's execute. Ooh, 13, and then it has been changed to 18. So it is working exactly as described over on the whiteboard. Let's go ahead and jump out of here, Logan. All right, so let me take control. I'm going to jump back over to my whiteboard real quick. So now we have looked at a very simple declaration, and then next line, initialization. Now, we can mix those together. We can do stuff like this. I want to create an integer that is an X. Let's go ahead and finish that off. And it needs to start out with the value 5 in it. How cool is that? Now we're declaring and initializing. So declaration, initialization in the same line. So this line will produce the following results. So it says, memory location established, called X. Value 5 assigned. Next line, ready to process. So let's show that real quick, Logan.
All right, I guess we could just go back
Just
to
do
where
it with
we
that.
where
So
we
do X equals 22. Now let's take out those assignments in there.
to take out 5 and 13.
Okay. And yeah, we can leave the other one in there because we can show it's going to print out the first time around 22, and then the next time it's going to print out 27 because it added 5 to that 22. Let's go ahead and run it. Ooh, 22, 27. So you'll find that declaration slash initialization all in the same line can be very handy when you're going to declare a variable that has to start out with a specific type. There's no reason to write it on 2 lines, right?
Right. Like I was going to say, if you know you're going to have, and call it a default value in that variable when you're about to use it, it would just be kind of annoying to always have to put 2 lines of code or 2 statements in to get your variable up and running.
Absolutely.
Whereas if you declare and initialize on the same line, that can simply be a lot more convenient.
You got it. All right, let's go ahead and close that. And just a couple more things I want to show real quick, because I know I've been going on for quite a while. We also have the ability to declare multiple variable types of the same type in the same declaration line, all in the same line. So what is he talking about? Well, let's say that I had an x and a y. I could do this. Int x, comma, y. And what this is going to do is create x and creates y. What's in them?
No, they're unassigned. So
they're unassigned. We don't have anything in them. By the way, so that there's no confusion with our beginners out there. These are separate lines. This up here was an example of one running program. Now we're just showing different examples. I don't want anyone to get confused trying to think in their head execution from the top down.
Right, that first one was all part of the same thing where we were showing declaration and then assignment and then using it.
Right. And I'm going to cross this out because this was a no-no. All right. So we can do int x comma y. You like that no-no thing, did you? Logan giggled. All right, so int x, y, this made 2 variables for us. This right here would have been it's the exact same thing if we would have done this. Int x, that is an n, I promise, and int y. Same exact thing. It's just handy being able to do it on the same line. And if we can do this, we can also do the same type declaration slash initialization. So I can say, again, separate program. You can't have in the same program. You can't say int x, and that's just not going to work. Not line after line. So I'm going to come down here and say int x equals 5, comma, y equals 8. Terminator. Okay? And this is going to do the same thing that we saw right here, except it's going to create them and then put a 5 in and then an 8 in. So it's going to declare and initialize all on the same line. And I'm not just limited to 2. I can put another comma in and I can do another. The key thing here is that each of these variables that you are declaring are of this type. They're all of the same type that starts out at the beginning of the declaration. Okay? Anything you want to add to that, Logan?
No, again, it's just shorthand for, like, let's say you want a handful of variables all to hold the same type of information, possibly to even be related, because with your starting x and y, that could possibly be a coordinate on the screen.
That's right.
But you want to use them at the same time. They hold the same type of information. You can do a kind of shorthand or more convenient initialization and declaration by just saying that, okay, we know these are all going to be ints, and let's just declare them all in the same line.
Exactly. Now, let's jump back over into Visual Studio real quick. And can we give them a couple examples of what happens if you don't use stuff? See, if you don't use a variable, or if you declare one, first if you just declare one and don't use it, it's just going to let you know, hey, you're never using this. So if you want to just set a couple examples up just to show them. So here, again, Logan is actually going in and doing some work with x, and it's giving us the error that use of unassigned local variable x. So go ahead and set x equal to 5. And go ahead and do, comma after that. And let's go ahead and say y equals 3. Okay? So now this is just to point out that we are doing, now go ahead and compile. Watch this.
I see what you're going for.
Now we got a warning. Check this out. The variable y is assigned, but its value is never used. This is not an error. We can indeed run our application, as you see here. But the compiler is being kind enough to let us know that we have created a variable that we have never used. Now, if Logan also does an int real quick and does another integer, make up whatever, so int level. Now, go ahead and compile. Okay, check this out. So the variable level, it's declared, but it's never used. So the compiler is going to keep you up to speed when you put variables into place but you don't ever use them. That's why if you recall back to the Hyperion project, remember when we went through, we first put the framework in place, and then we turned around and we started putting the method framework in place and all of the variables or the field members in place. And we started having a whole bunch of warnings. And all of these different things, they were being declared or defined, but were never being used. And as we added more and more code into the Hyperion project, each time you built the solution, more and more of the warnings went away.
That's also why I was ignoring the warnings to begin with. It's because I knew I was going to be using those later.
Now, good programming practices to follow. Try to make sure don't just say, oh, it's a warning, no big deal. All right, my code's ready to be shipped.
Right. I mean, if you're half done with something, of course you're going to get warnings like this when you define and you just haven't put a variable into use. But when you're getting towards the end, when you think, okay, my program is pretty much done, all of its functionality is in place, if you're still getting warnings, look into those and see exactly what they are, because chances are, if your program is done and you're still getting a warning about a declared but never used variable, you can probably just get rid of the variable altogether.
That's right. So that's pretty much everything we wanted to talk about. Now, the compiler is really smart. I can say int level, and then later on down in main, I can initialize it. What's going to happen is the compiler will search all possible code paths to see if we're going to reach a point where the variable will actually get initialized with something. And if indeed it does, then it's going to be happy with it. Now, this particular case is cool too. So the variable level is assigned, but once again, it's never used, the same as y above. But if we used it, all is good.
Right, so if I were to take one of our right lines and put in level, and now we build, that completely takes away the warning.
Exactly. So again, compiler is real smart, but the big thing to remember, when creating your variables, make sure that you initialize them. You're making them for a reason. They're to store data. You've got something in mind. Put the data in them. That's important. Or the compiler, it's not going to like you so much. So I think that's everything we wanted to talk about, Logan, except let me go ahead and jump back over. Is there anything else that you want to add before I jump out of this?
Only one thing to mention, in that a practice like this where we have a declaration and then some code goes on before we initialize, generally you'd want to avoid that. Even though it's not a problem with the compiler, it just makes the code harder to read, because you might be in a case at this right line and decide to use level, but you can't yet. It's not initialized. So while this is legal, it's not exactly good practice. You would usually want to initialize rather soon, declare, and then immediately turn around and use or initialize that variable.
Or just do the declaration and initialization on the same line.
Right, and if we knew we wanted 8 in it, this would be a lot more efficient visually than doing 2 lines.
Very nice. Okay, so is that everything?
Yeah, oh yeah, I'm happy with things now.
All right, again, basic, fundamental look at variables. So let's go ahead and jump back over here to our whiteboard real quick. And to sum everything up, here's what I'm going to do. I'm going to go ahead and create a new sheet of paper. And I'm going to say that you are not yet a certified expert on variables. All right, not an expert. I'll throw on in there so it makes more sense. On variables. Why not? Because some things that you need to understand, but you may have heard these terms thrown around here and there. You need to understand scope. Variables cannot be seen from every place within your application, in most cases. Scope. Next thing you know, a variable's life. A variable's life? What are you talking about? Yes, indeed. We talked about the garbage collection system. Variables will get swept up and thrown away when they are done being used. So later on, we're going to start focusing on variables getting thrown away.
And not only that, it can tie back into scope. You've seen just a tiny piece of this when you notice that a variable doesn't exist until it's declared. You could even look at that as part of the variable's life. You can't define X at the end of your program, but then go back and use it before it's defined.
That's right.
It hasn't come into being yet. Its life hasn't begun yet.
That's right. And then finally, I'll just throw this in here because it is important. Casting, yeah. We are going to need to be able to convert data types. And you have seen this already, as a matter of fact. When Logan was working with Velocity in the simple Windows application where he had a button bouncing around the screen, he stored his velocity as a float value type. But when dealing with coordinates on the screen, that's an integer because we were dealing with pixels. So we didn't have a pixel location of 33.6. It was just at pixel location, X 33, Y 16. So we had to convert our velocity over into an integer value type. So casting, that's the term. We're going to need to understand casting, and we'll be covering that in depth a little bit later on. And that's the three big ones right here that we're going to need to make sure that we cover. So with that, while you're not yet an expert, everybody should have a solid foundation into the idea of variables. And that is going to wrap up this video. Thanks a lot.